Apache Spark is an open-source unified analytics engine for large-scale data processing. Spark itself was created to overcome the limitations of early big data frameworks like Hadoop and MapReduce. In this lecture, I want to go into the history behind these technologies that have shaped modern data processing. Let's start by talking about big data. Big data refers to data sets that are so large, fast-moving, or diverse that traditional data processing tools and technologies can't handle them efficiently. It's often described by the 4 V's. Volume. This relates to the massive quantities of information, from terabytes to petabytes and beyond. Velocity. This refers to data arriving at high speed. Variety. This refers to the mix of data formats, such as structured data, semi-structured data, and unstructured data. Veracity. This is the uncertainty or trustworthiness of the data. Here, in 2025 alone, the volume of digital data is expected to swell to roughly 181 zettabytes. That's about 402 million terabytes created every single day across devices, applications, and sensors. This explosive growth outpaces what traditional single-server databases and on-premises clusters were designed to handle. In traditional data warehouses, as your data grows, you simply add more CPU, memory, or disk to your server. This is known as vertical scaling. Vertical scaling means making a single machine more powerful by adding resources, more CPU cores, extra RAM, or faster storage. As it continues to grow, you can keep vertically scaling the hardware. However, vertical scaling runs into physical and economical limits. There's only so much memory or CPU that you can cram, and high-end hardware becomes disproportionately expensive. So there was a need for things to be done differently in order to meet the growing demands of data processing and storage. In 2004, Google introduced MapReduce, a framework designed to process massive data sets efficiently. They also described their distributed storage system, the Google File System. MapReduce became a foundation for distributed data processing. 2 engineers, Doug Cutting and Mike Caffarella, were inspired by Google's research. In 2006, they developed Apache under the Apache Software Foundation. Hadoop had 2 main components. HDFS, which stands for Hadoop Distributed File System, is a scalable file system that stores data across multiple machines, and MapReduce, which is a distributed processing engine that followed Google's MapReduce model. Hadoop made big data processing accessible to organizations by allowing them to store and process data using clusters of commodity hardware. Rather than vertically scaling software, you could leverage distributed processing and storage. This is known as horizontal scaling. Horizontal scaling spreads the workload across many smaller, cheaper machines instead of relying on one single powerhouse. So, for example, let's say you have a massive data set. The massive data set is broken down into smaller partitions and stored across multiple nodes as part of the Hadoop distributed file system. If you need to perform any processing on this data set, then it can be done on MapReduce by leveraging multiple machines to form a cluster. Each machine or worker node in the cluster works on an individual partition of the overall data set. A cluster manager coordinates and divides tasks among the workers. This model can grow almost without bound. If you need more capacity, you simply add more nodes. This distributed approach allows companies to process petabytes of data efficiently by spreading the work across many machines, by minimizing data transfer and processing data locally. Hadoop and MapReduce handle large-scale batch jobs in a scalable and fault-tolerant manner. This architecture was crucial for big data pioneers like Google, Yahoo, and Facebook. While Hadoop was revolutionary, it had one significant drawback: disk I/O. Intermediate results were read from and written to disk at each step of processing, which slowed down performance. This made Hadoop inefficient for iterative processes like machine learning and real-time analytics. In 2009, researchers at UC Berkeley set out to solve Hadoop's performance issues. They developed Apache Spark, an engine designed to process data in memory, bypassing the repeated disk I/O bottlenecks. Spark gained widespread attention in both research and industry. Spark introduced several key improvements over Hadoop. In-memory processing made Spark up to 100 times faster for some workloads. Spark also supports multiple types of workloads, including batch processing, real-time streaming, machine learning, and SQL queries. Spark works with various storage systems like HDFS, Amazon S3, and Azure Data Lake. These improvements allowed Spark to become one of the most popular big data engines today. In 2014, the creators of Spark, including Matei Zaharia, co-founded Databricks to provide managed Spark solutions for organizations. Over the next decade, major companies like Netflix, Alibaba, and Uber leveraged Spark for data pipelines, real-time analytics, and machine learning, solidifying its position as a leading data processing framework. Today, Spark continues to evolve with support from both open-source contributors and platforms like Databricks, which have expanded Spark's ecosystem with features such as Delta Lake, structured streaming, and machine learning workflows.